Why India lagged in ramjet technology and how DRDO has finally cracked it.
Well, Defence Research and Development Organization has carried out successful demonstration of solid fuel ducted ramjet technology,
which is the new elite small international group that India has finally entered, and why the ramjet SFDR technology matters so much. On February 3rd, 2026, that is yesterday, India crossed a technological threshold that very limited countries have crossed in the world. And this is not just about a scientific achievement, it is about a strategic correction of the long-standing vulnerability with the successful testing of solid fuel ducted ramjet technology, which has placed India's with successful DRDO's accomplishment on world's map of ramjet technology. Hello everyone, welcome to Vajiram and Ravi's Flash News. My name is Shubhangi Singh and today we will be looking into that why this ramjet technology is very important, how this has kept us vulnerable, what are the setbacks that we have seen and what we have achieved on this particular date with this successful test. So let us begin with understanding that what exactly are we talking about in terms of achievement. Now when we are talking about this particular test, this was carried out by Defence and Research Development Organization, and this was conducted in integrated test train facility in Chandipur off the coast of Odisha. Now what exactly was tested was the solid fuel ducted ramjet technology. Now what is the kind of technology that we are talking about here? It is a critical propulsion technology which is very important when we are talking about long range and especially air-to-air missiles. Now in this context, it is very important for also us to establish right here that with this particular feat, India has been placed in a global elite club where very limited nations have achieved this technology and on their own. In the very same context, another highlight that you should remember that this particular test is not just about a single missile. This particular achievement, it is a platform level, ecosystem level achievement which will change that how our missile ecosystem and especially long range air-to-air missiles work and have performed. Now we will be starting from scratch, understanding every bit around it with the first thing that you might have in your mind, that what exactly is the ramjet technology that we are talking about. So when we are talking about ramjet technology, before that we have to understand propulsion methods or propulsion mechanism. What exactly is? When we are talking about the word propulsion itself, it basically means the force that pushes the vehicles or drives the vehicle, correct? So when we are talking about missiles or rockets, the propulsion technology is that technology which helps that missile or rocket to move, to drive, to go ahead. So in that context, propulsion technology, we have one specific technology, that is ramjet technology. Now how does ramjet technology work? Ramjet technology works in a very simple mechanism where the inlet is of air. So the engine is air breathing. If you see in this given diagram, you will see the inlet and this is where air is incoming. Now what is the purpose of this incoming air? Because this air, when you assume this is moving at speed, the speed of air incoming is equally faster. So this is the place where the incoming air is gradually compressed as it enters. And because there is no presence of rotating compressors or any turbine where we get to see the generation of movement of air, this is where the air which is present, and because of the movement of rocket, air is coming and because of this motion it is compressed. Now because of this compression we get to see that the combustion which is taking place, that is facilitated, and that is the propulsion, the force that creates the force for the movement of the particular rocket or missile. Now similarly when we are talking about ramjet technology, because in this context we are talking about a specific one, that is solid fuel ducted ramjet. Now what is that? So when we are talking about SFDR, we have to understand in SFDR, when I was talking about this combustion stage, this is where we have presence of solid fuel. And this is the place where solid fuel is burned gradually, and atmospheric air is the one which facilitates that because it moves through the duct. That is, it is why solid fuel ducted ramjet. Now, it is different from rocket motors that usually exist because rocket motors have limited burn, and because of that burn we get to see the coasting phase. Now, when we are talking about coasting phase, we have to understand it is talking about a particular phase when a particular item, object keeps on moving in a forward direction. Let's just say this is the direction, and at this point there is no force or energy which is being given. The engine is not working, let's just say. So, because of the momentum, it will keep going forward. Now, from that point, the coasting phase begins, when the object is moving just because of the momentum, not because of energy. Now, in this context, because there is short burn, the coasting phase is longer. If the burn is longer, coasting phase will begin from here or later, and that is why we get to see loss of energy for the movement of object, and that movement, that distance is limited. But when we are talking about ramjet, because here we get to see facilitation of airflow, and that is atmospheric air, we get to see that there is sustained thrust, and that is available throughout the flight. That means if there is a missile which is present, it will have a longer range, it will have better speed, and also better terminal performance. Terminal, that means the end point. What that missile has to do at the end point, that will be decided by the speed and the thrust. So, if better speed and longer range, then the final terminal performance will also be more appropriate, more precise in this context. Now that we have a fair understanding of SFDR and ramjet, now let us move to understand that how exactly this has been tested. Now, the missile tracking has been done so as to assure that SFDR and the ramjet technology that we are boasting is working, is actually working. So, for that, a proper telemetry system, radar station, and also electro-optical instruments were used along Bay of Bengal, and after that we got the confirmation that yes, there was successful ignition. That means the first part, the sustained operation of ramjet, there was proper fuel control, fuel flow control, and also proper structural and thermal stability. Now, this has been confirmed. Another factor that we need to consider here is the fact that it was not just coming from DRDO, it is coming from many scientists from multiple DRDO labs who have monitored the tests. And the data has been collected from all these scientists, and it has validated that the propulsion system is also working and the control system is also working and is in place. Now, we will need to know that when we have this particular technology, then now that we have this particular technology, how this will help? This will help us in modern air-to-air combat. Because when we are talking about modern warfare, the problem here is, and the main feature of modern warfare is that it is dominated by beyond visual range engagements. That means a target needs to be engaged or targeted, which is something you cannot see. It is beyond your visual range, and it is not, I am not talking about human range, I am talking about machine ranges as well. This is where ramjet powered missile come in the picture, because they are giving longer engagement range. This also facilitates longer no escape zone, especially for the target, because they have very less time to react. And even in the terminal phases, these missiles have high terminal energy, especially against maneuvering targets. Even if the target is maneuvering, because the end energy, the terminal energy is enough for the missile can engage that target. So, in this context, this is a direct addition to our modern air-to-air combat, and it will also help us in targeting enemy aircraft where they have less time to react, They will find it harder to evade it. No escape zone is very limited, because even if they are taking sharp turns or countermeasures, that means with this particular technology, we have a decisive edge, especially for Indian Air Force and the future air battles if we have to prepare for. Now, you have to understand the timing, the significance of timing of this particular test. When we are talking about increased defense spending in this budget, this also highlights the fact that how the global landscape has become very chaotic, and we need to be prepared for it, not just from one end but two ends, because we have China on one end, Pakistan on another, and we have very limited friends in our neighborhood. So this preparedness not only comes in terms of infrastructure, defense infrastructure, but also technology. So this is another significance that highlights that it is well in time, where it can be replicated and actually brought in real time. Now, in this note, we will be moving to understand another important dimension right around it. That brings us to the backstory more, because as of now, India has tested and successfully tested, but till date, India did not have it. Now, because of that, India had a strategic setback, not once, not twice, multiple times, because historically, India has been dependent in terms of imported air-to-air missiles and the propulsion systems. Now, the problems were multifold. How? Now, when we are talking about technology, there have been multiple technology denial regimes which have been set in place, such as Wassenaar Agreement, then we have MTCR, we have NSG. All of these are technology denial regimes, and that is why they are the ones which restrict any kind of access to advanced propulsion. That means when we are talking about defense related technology, especially these regimes are made to ensure that technology and its access is left with only the participants of the groups or the agreements, and it is not accessed by any other. Now, India has been a recent participant to some of these groups, but before that it was controlled by these technology denial regimes. Now, another key problem here was that India had limited freedom. Even if they imported from somewhere, they had very limited freedom to make it in a better model or modify the missiles at all. And if we are talking about platform integration, if that India wanted to do, that was only possible once there was proper foreign approval. So you can see that the dependence is one part, but the dependence has been created in layers as well, which makes it more difficult to hold any autonomy, hold decisiveness over the technology that you have already bought. So in this context, India had been very dependent and hand-tied as well, and that is what restricted our missile ranges, because we did not have an indigenous ramjet technology. That is why we had to limit ourselves to shorter missile ranges as compared to our adversaries around us. Other than that, the terminal performance as of now till date remain absolutely inferior again compared to adversaries. So in this context, till date, even if we had the modern fighter aircraft, we still were vulnerable in terms of operations, we still were vulnerable in terms of strategic presence. So in this context, it was a very difficult position, and now that difficult position has been overcome by India with this successful testing. Now, as I mentioned that there are only very limited countries who have achieved this till date. Why is that so? This is because this is a very engineering wise challenging method in itself, and overall if any failure occurred, it could lead to multiple problems such as combustion instability, structural failure, or loss of missile controls as well. So that was a not just challenging, rather dangerous task to intake. But once India has achieved this, and India's success in this context reflects that our defense research and development is maturing, and when we are talking about long-term investment, there is a lot of scope when we are talking about indigenous capability and the expansion of its potential through better investment. Now, in the only thing I want to discuss here is that what are the gains and strategic implications? Now that we have SFDR technology with us, it not only enables development of indigenous long-range air-to-air missiles, it reduces our dependence and it reduces our imports. That means pressure on our current account also decreases. It helps us in being strategically autonomous and also with special reference to defense manufacturing. It will help and improve our combat effectiveness, especially when we are talking about our Indian fighter jets, which are modern, which are futuristic. And this is where India gets yet again placed as a credible advanced missile technology power. So this shows that it is a long time due turn that India is taking from just being a technology importer to technology developer and innovator as well. Now, what are your thoughts on this? Let me know in the comment section. That was all from my side. Thank you so much.